Hello. So in this demo, we will show the difference between transfer learning versus training from scratch. And in particular, we will show two different deep reinforcement learning approaches for managing the VMs of a data center. Let's see again our problem scenario. And actually, this is a reminder from the previous conversation. So we have our system model here where this large box indicates a data center, and inside we have some hosts or some fixed nodes. Then we have a job queue or an application queue where incoming applications are staying there in the queue until we have enough resources to place them. So an application needs a virtual machine, a VM, in order to run. So we have a broker which manages the VMs inside the fixed nodes. Depending the load, the broker have to find the optimal virtual machine allocation policy in order to balance both the resource efficiency but also the application waiting time. So we want each job not to wait for a long time in the queue, but also we do not want to waste resources. So, for example, open some virtual machines that do not run any application. So let's see what we will see in this demo. So the goal of this demo is to show the performance comparison between transfer learning and training from scratch in different scenarios for VM management in a cloud data center. So this will highlight what benefits or what we gain when we reuse some knowledge, when we have pre-trained models, instead of trying to train a model for each problem from scratch. So we want to reuse as much knowledge as possible in order to avoid excessive retraining. In order to measure the performance differences, we have three different metrics. The first one is the application queue ratio. So at each moment in time, how many applications that have arrived are actually waiting. And we also measure the actual waiting time in seconds of these applications. The other metric is the total allocated VM cores. So this is an approximation to measure the overall energy consumption of the data center. And we also measure the unutilized VM cores. So this will give us an approximation of how much resource efficient we are. So the decisions of the DRL, how much energy efficient are, and in order to avoid over provisioning. So we will start two different experiments in parallel in a data center with 16 nodes. The first model will try to learn from scratch, and the second model is an actual pre-trained model which has already trained to do the exact same thing but with 8 nodes. So it has learned to perform VM management but in a less number of available nodes. So we will see if this trained model is able to adapt and apply the trained knowledge to a different, a larger scale scenario. And also as a bonus, we will compare the DRL performance against three simple rule-based approaches. And we will actually see these three things in the demo after showing the performance. So we will see that at first, rule-based approaches outperform the from-scratch model. Also, we'll see that the deep reinforcement learning approach aims to surpasses the rule-based approaches after convergence. So this means that this from scratch model uh, in the end outperforms the rule-based approaches, but this takes a lot of time to do. And the third and the more critical point is that we will see that the transferred model, the transferred DRL model, manages to outperform the best of the three rule-based methods within 2 minutes. So this means that it actually reapplies knowledge and not only manages to out outperform the from scratch model, it also outperforms the rule-based model very fast in a very short period of time. So we will start first the experiments. So as you can see here, I have set up in this configuration file two experiments. The first one is to train a model from scratch in this scenario in 16 nodes. And the second one is to transfer a new pre-trained model to the same scenario with 16 hosts, but the model we are using to transfer has been trained with 8 nodes. That's why we named this experiment 8 nodes to 16 nodes. So let me run the experiment and also go to the TensorBoard in order to see the performance difference. So I'm closing everything here, and these two are the experiments I started running right now. As you can see, these are all empty. We will start seeing some dots that will eventually become the learning curves of these two models. As you can see, these two models are being trained right now. So we have our first dots, our first performance. Let me refresh in order to get both okay. So as you can see here, this green dot is the first reward that achieved the from scratch model. You can see from the name, the green dot indicates the model that is trained from scratch. The orange dot is the transferred model. And as you can see here, even on deployment, so this pre-trained model hasn't been trained for this particular task, has been trained for a slightly different task to perform VM management in a different amount of available nodes. But even without having trained enough for this particular example, it manages to outperform the from scratch model. And as you can see here, these two models are going to train for a long period of time. But in order not to wait, I have already done this experiment before. And if you can see here, these are the finished learning curves of the two models. So as you can see here, if I close these two that I started running, and we will see the final learning curves, we will see that the blue line, which indicates the model, the pre-trained model, manages to have at the whole time a better reward. So it started very much higher and continued to go higher and higher. And as you can see, the final reward of this pre-trained model aims to perform better even when we compare the final and the best performance of the from scratch model. So this thing here, where I am pointing to, means the higher is the higher performance, the higher reward that after 2 million time steps the from scratch model managed to perform. But with this transfer, the model aims to not only perform better from the start of the experiment, but also manages to outperform the best performance of the pre-trained model. And here we can also see the other metrics. So this is the job queue, the application queue ratio. As we can see here, the pre-trained model has a little bit higher training application queue ratio. This is because we want all these metrics, so this metric and also this metric and also this metric to be minimized. So as you can see here, this model, the blue model, which is better, we can see it from the overall reward. So this is what all models try to maximize. They try to maximize this overall reward, which is a combination of this Q ratio, the allocated VM core ratio, and the unutilized VM core ratio. And as you can see here, the blue model performs a very good overall by minimizing this metric, and slightly increasing this metric. But overall, the blue model performs better because the combination of all these is better if we measure them together and put them in an overall reward function. And here I have also plotted the actual waiting time. So as you can see here, for example, this means that overall the average application waiting time is 7 seconds, while the gray model has 3. So this in particular is better for the gray model, but the gray model does not perform well in terms of allocated cores. So this means that the gray model, the from scratch model, has much larger energy consumption. And also from here we can see that the gray model has much larger unutilized cores. So this means that it is not very resource efficient, so it opens VMs that are not used in the end. So for example, here I am indicating that the gray model has on average around 60% unutilized cores. So this means that 60% of the resources that the DRL agent opened, actually they are not needed because they don't run anything. The applications are much less, so we do not use these cores. But in the other hand, we can see that the trained model, the pre-trained model, has only around 10% of unutilized cores. So let's also see the rule-based approaches. So let's see the overall reward. As you can see here, these three horizontal lines are the rule-based approaches, and why they are horizontal, because these rule-based approaches are deterministic. And it also means that they do not learn. So their initial performance is actually their final performance. They always do the same thing over and over again in all episodes. So they do not have the potential to learn anything new. So these are their performances. And if we compare them with other DRL approaches, as you can see here, this is the from scratch model. As you can see, it initially starts very bad, worse than all rule-based approaches. Sorry, and then it requires a lot of time in order to surpass for example, the best reward of the rule-based. So this yellow line is the best rule-based approach. It has a reward of minus 5.7. And let's see how much time it needed for the from scratch model to reach that best reward. So as you can see around here, okay, as you can see here, the gray model has minus 5.7. This is approximately 1 million time steps or 5 hours. So we need 5 hours to train a DRL model to perform better than the best rule-based approach. But if we compare it with the transfer approach, as you can see here, from the beginning it actually performs better. But if I zoom in, as you can see here, the first time the blue line surpasses the yellow line is around 2 minutes. So in 2 minutes, the transferred model aims to surpass the best rule-based approach. So that's all from my side. Thank you so much. If you have any questions, feel free to ask.